Today we will see the depth first search, breadth first search for a given graph, and we will also find some valid breadth first searches also. So let us start. The first thing that is required here is we will have the breadth first search output. We will have the breadth first search output. Then what you want to have next is we also want to have one Q counter for this. One Q counter for this. So I will make some Qs, areas, probably how many nodes are there, accordingly you will be trying to have the number of sections in the queue. Okay, so let us start with the vertex 1. So I have 1. Now because I have already visited, so what I will do is I will write here 1. Now I will move on to my next, that is the no vertices, exploring 1, because I'm going to explore 1. Who are my next neighbors? I have to check. So 4 and 2 are my next vertices, wherein this first has been introduced already in the queue, and now it has been explored. And I will also see that this 4 and 2 also are introduced in the output because these also I have visited. Okay, so in the next position I am with this 4 vertex to be explored. Now 4 is connected to 1 and 3, but 1 already is visited, so we can't introduce 1, so we will go for a 3. I have 3 as a visited vertex. I have to put it in the output. Now in my queue, I see that there is 2 in the sequence. So I will be exploring 2 and put those no, vertices to the queue, that is a waiting list. Now the 2 is having how many adjacencies? 1, 3, 5 and 8 and 7. So 1, 3, 5, 7, 8 are the adjacencies, out of which 1 has been visited, 3 also has been visited. So I will not introduce these 3 vertices. So I will, what is introduced is, I will be introducing the unvisited one. So 5, 7, 8. So 5, 7, 8. And I have visited, so I will put them here in my output of visited list. Now I can see who is in the next sequence because I have visited, I have explored, nothing is to be explored yet. So I will cross that. Now who is there to be explored? 3 is there to be explored. Now 3 has 2 members, 9 and 10. So where I will put them? In this queue, in the queue I am putting them in the end here. So 3 has been explored now because they are new members. So I will putting them here as visited. So 3 has been explored. I will dequeue this. It is dequeued. You can call this dequeued. Then who is there in the next sequence? 5 has to be explored. Now 5 has how many adjacencies? 2, 8, 7 and 6, out of which 2 is visited, 8 is visited, 7 also is visited. So I need not put them here. So what I will do is I will simply introduce a number 6 which is not only visited. I'll remove this from the list. Now who else is there to be explored? Number 7. Now 7 adjacencies are 2, 8, 5, but they already are just visited, so nothing to explore 7. 8, all are at this 2, 5 and 7 are there, but they are already visited, so I will not introduce 8. I will just remove this. After that, suppose I want to explore 9. So if 9 is there, we don't have anything for this 9. So that also is dequeued. And similarly, 10 also has been dequeued. And 6, there is nothing. So 6 also has been dequeued. And I had to be introducing here the 6th one. So we have the BFS output, which is seen here as one of the searches. Now you can have different searches. Suppose I have, this is one output. I can go for the output in the second fashion, or you can say this is not volatile, this is a number 2 BFS. Suppose I start from 4. Suppose I start from 4. This is my start. I will just start from 4. So what will I do? I have to make out output here. I will again make a new queue. How it will be? How it will be looking like? So I will see that I will be putting like 4 to start list. The queue again will be there arranged like this. I have some 9 to 10 members here. Okay, next. So if I want to have the output for the start 4 means the first member will be 4. I have visited 4. Now to explore 4, I am having two adjacencies. I am having 1 and 3. So I will be putting them here in the queue and I am putting them in the visited also. Now 4 has been explored. Now what I will do is I will be exploring 1. Now who is adjacent to 1? It is adjacent number is only 2 and 4. So 4 already visited. So I will not introduce that. So I will put here in the visited one. After this, 1 has been dequeued. 1 has been dequeued. Now I am having 3 in my queue. So 3 way to be explored, I have two numbers, 2 and 10, 9 and 10, sorry, 9 and 10. Now 3 has been explored. After that, I have 2 in my order. Now 2 has 1 and 3 adjacency, 5, 7, 8 adjacencies. Out of which 1 and 3 already have been done. So I have to go for 5, 7 and 8. So I will introduce the visited one, 5, 7 and 8. Now I will remove this from the queue list because it has been already explored. Now who is there in the 9? So 9 has nobody to explore, I will remove this. 10 has nobody to explore, I will remove this. Now 5. 5 has 2, 8, 7 adjacencies and 6, out of which 2, 8, 7 are already visited. So only one that is remaining is that is 6. So 6 is enlisted here in the visited also. So I will remove this 5 dequeued. Now if I want to see the 7, the adjacencies for 7 are 2, 8 and sorry, yes 2, 8 and 5, but they are already adjusted, so I will remove this, nothing to explore. Again 8 has nobody to explore. 6 also has nobody to explore because already it has been included. So my search stops. So this is my BFS output for a start which is starting from 4. So have you can have many BFS outputs depending on the start vertex. Thank you.